Finally, today we're going to look at the difference quotient. This video may be slightly longer because this is critical. This is something that is going to be part of a definition, a very basic definition in calculus for those of you who are going on, whether it's business calculus or the 4-semester calculus sequence. Yes, the difference quotient has a very ugly look to it initially until you get used to it. But I want you to realize that it really is absolutely nothing new. This is a restatement of the slope. The equation that you've used for slopes so many times looks more like this. But in this case, we're going to let x2 minus x1 be h. Notice that my x moved from x to x plus h, so the difference there would be h. And these are function notations instead of y values. But this really is just the slope formula, and we call it the difference quotient, and it is going to be a very basic and very major part of a definition in calculus. Okay, let's take a look. I want to start with linear for a reason. I have shown you that the difference quotient is actually the slope formula. So I'm going to start with something where I'm expecting my answer to be 3. Why do I like to start with something that I know what the answer is already when I could do it easier? Simply because I like being able to know if I got something correctly done. Now, those of you who are really good with algebra may want to do this in one step, but I'm going to break it down into smaller steps for those to whom it is new. So I'm going to start off with the first part of that difference quotient, which was just f of x plus h. To do that, I'm going to substitute x plus h for x in my original function. Then I'm going to simplify by distributing the 3 through. And then I'm going to look for like terms, but I'm not going to find any. By the way, that happens a lot in this. Okay. All right, then I'm going to say f of x plus h minus f of x, because that includes my entire numerator. So be careful. There's a minus sign that the teacher has warned you. You're going to mess up on a couple of times if you're not very careful. So here's f of x plus h, and yes, these get very long, minus f of x and I'm going to now subtract. 3x minus 3x is 0. 3h minus no like terms is 3h. And then negative 4 minus negative 4 is a 0. So my numerator becomes 3h, f of x plus h minus f of x over h. So f of x plus h minus f of x was 3h over h leaves me with 3, which is exactly what I was expecting to find. Now let's take a look at an example where I can't just look up here and tell you what my slope is, because you know and I know that on a parabola the slope changes. So let's see if we can use the difference quotient in a case where I don't already know the answer. The steps are going to be the same. First thing I'm going to do is find f of x plus h. And again, this is why I keep telling you, use your formulas. They're going to save you a whole lot of time because, see, I don't want to have to write that out and full it out. I just use my formula that says that's x squared plus 2hx plus h squared plus 1. And then I distribute the 2 through. 2 times 2 is 4. 2 times 1 is 2. And plus 1's just hanging on. Now I look to see if I can collect like terms, and I don't have any to collect. I'm actually very comfortable with that by now because I usually don't find anything to collect there. Minus f of x. Let's finish off that numerator. So here's my f of x plus h. 2x squared plus 4hx minus 2h squared plus 1 minus f of x was 2x squared plus 1. Equals, let's do the subtraction. 2x squared minus 2x squared is 0. 4hx, no like terms, so he's just going to stay 4hx. Minus 2h squared, no like terms. But 1 minus 1 is 0. So f of x plus h minus f of x. Please note this. Every term that's left up here has an h in it. That is not a coincidence. It happens. So x plus h minus f of x over h. So this is 4hx. Let me finish it out. Minus 2h squared over h. Now let me warn you about canceling out this h because I have a lot of students who mess it up. You can't just cancel out one of these h's because you see that open minus sign. You cannot cancel through an open plus or minus sign. The way most of you will find it simpler is to actually break down the definition of subtraction of a fraction. To subtract, you get a common denominator and then subtract the numerators. And so since that's a subtraction in the numerator, I can break it back down to its common denominator. Then I can cancel the h's here, leaving 4x. And I can cancel one of those h's with that one on bottom, leaving a minus 2h. Okay? Lengthy problem, but if you take it step by step, it's really not all that bad. And one last and rather lengthy example before we call it quits for the day. If f of x is negative 2x squared plus x plus 5, determine the difference quotient. Again, by the time you finish practicing this, you should know this difference quotient. It really is just the slope formula. But in function notation, and always going h units away from the original x value. Alright, so I'm going to start off with just f of x plus h. And I'm going to substitute x plus h for x every time it occurs in my initial function. Okay, so negative 2 times, here's that formula again, x squared plus 2hx plus h squared. Is it wrong if I write 2xh? No, it's not wrong. It's just not proper. Plus, okay, I'm technically distributing the one, I guess you could say, x plus h plus 5. Now I've got to distribute the negative 2 through. That's negative 2x squared minus 4hx minus 2h squared plus x plus h plus 5, and there are no like terms. I've gotten kind of used to that by now. I hope you're getting there. Okay, so then I'm going to say f of x plus h minus f of x. Again, like I said, this is going to be lengthy because f of x plus h is negative 2x squared minus 4hx minus 2h squared plus x plus plus 5. Minus, here comes my f of x, and please do put it in parentheses, you will miss it otherwise. Negative 2x squared plus x plus 5. Then I go through and do the subtractions. Negative 2x squared minus negative 2x squared is 0. Negative 4hx had no like terms to combine with. Negative 2h squared had no like terms. But x minus x is a 0. H had no like terms. And 5 minus 5 is 0. Again, notice that my numerator, when I complete it, every term has an h. Okay, and then I'm ready to complete my fraction. F of x plus h minus f of x over h. So this is going to be negative 4hx minus 2h squared plus h over h. And I'm going to break that down into the fractions. So that'd be negative 4hx over h minus 2h squared over h. And I hope you will learn to skip this step. Plus h over h, which the h's cancel, leaving negative 4x, I'm sorry. The h, one h cancels here, leaving minus 2h. And h over h is 1, so plus 1. So my difference quotient is there. It can get rather long, it can get rather lengthy, but again, it is incredibly important if you're going to go take a calculus class. So practice the difference quotient until it becomes second nature and you know that, hey, I don't have any like terms, I did that right. Every term has an h in it, I did that right. Get to the point to where you're comfortable.